Welcome to Noble of Chemistry. Today we are going to start the topic is lanthanoid contraction. So lanthanoid contraction பார்த்தீங்கன்னா ரொம்ப இம்பார்ட்டண்டா கேட்டுட்டு போர்ட் எக்ஸாமினேஷன்ல கேட்டுட்டு இருக்கக்கூடிய ஒரு ரொம்ப இம்பார்ட்டன்டான ஒரு கொஸ்டின். Okay, so let us see how the lanthanoid contractions will be formed. So normally this is the rough diagram of the periodic table. This periodic table, it is in the atomic size, it is decreases left to right. So like this, it is size, atomic size, left to right get decreases. Left to right get decreases. But in lanthanide series present in the period, it is the sixth period, present in the sixth period and third group, sixth period and third group. All from the lutetium, lanthanum to lutetium, all these elements are present in the sixth period and third group. Okay. So in this process, lanthanum, first element lanthanum, cerium, praseodymium, neodymium, promethium, samarium, uranium, gadolinium, then next one terbium, then isoprismium, then holmium, then erbium, then thulium, ytterbium, lutetium. So these all the 14 elements are present in the first F block elements. So in this 14 element, from the left to right, it is a size get decreases. So look at that, it is size of that, and size of the lanthanum, it is that 181. So that size of the lanthanum, first one, it is 187, then 83, 82, then 80, then 173. So like that, gradually, it is the atomic size get decreases. Atomic size get decreases gradually. Okay, so right. So in the series, it is a lanthanum to lutetium, gradually atomic size get decreases. How the decreasing will takes place, that we're going to discuss now. Right. The first one, it is the first we want to check, it is the how the graphical representation of the lanthanoid ion. Okay. So graph, it is plotted between ionic radius versus atomic number. Ionic radius versus atomic number. It is gradually, it is get decreases. Okay. That lanthanum, cerium, praseodymium, like this gradually in size get decreases. Size get decreases. Why it is the size get gradually it is decreases? It is the some reason it is there, that steady decrease in the atomic ionic radii, that is be called as a lanthanoid contraction. So that's very important. That steady decrease, gradual decrease. Either it is the term it is gradual, or it is the term it is steady decrease in the atomic and ionic radii of the lanthanoid element with increasing the atomic number, that we called as a lanthanoid contraction. Okay, so lanthanoid contraction. In the previously, I've explained this. And so now let us see the how it is that, and what are the reason it is for existing the lanthanoid contraction. What are the reasons? The factors, some factors are there. Then the first factor, effective nuclear charge. The effective nuclear charge, in the sense, it is an attraction between, the nucleus and attraction between nucleus and outer shell or valence electron. Nucleus and valence electron. So that's we called as effective nuclear charge. Okay. Then second reason it is shielding effect or screening effect. Shielding or screening. So that we know very well in our periodic classification chapter already we are discussed. It is your s orbital having the more screening, then p orbital, then and d orbital, then it is f orbital. So that d and f orbital, it belonging to the poor screening effect. Screening effect, that's very important, children. This one, it listen me very carefully. Poor screening effect, that s and p orbital, it is having the, it is very stronger screening. Okay, so stronger screening effect, stronger screening effect. I will show with the demo. I will show with the experimental methodology. 1 second. And next one. So this is that in the outer shell electron. Okay, this is the nucleus. This nucleus present inside the inside the atom. It is this and all. It is the outer shell electron. All it is the outer shell electron. Electron be present in the outer shell like this. Electron it is present. Now it is a force of attraction between the nucleus and outer shell electron. Some force of attraction it is existing between nucleus and the outer shell electron. Nucleus and outer shell electron. So that is effective nuclear charge. Look at here, attractive force. So where it is attractive forces, it is there in the center of the nucleus to outermost shell electron. Otherwise, we used as a term, it is a valence electron. The attractive force between these two systems that we called as a effective nuclear charge. That is we called as a effective nuclear charge. Okay, so that is, it is denoted as a effective nuclear charge. But due to the effective nuclear charge also, size get decreases because due to the attraction, this electron it is moving towards like this. Okay, due to the attraction, the outer shell electron it is moving, it is towards to the nucleus. So that is size it is get. Okay, usual actual size this. Due to the attraction, it is this electron it is moves towards to the nucleus. The size it is get decreases. That decrease in size due to effective nuclear charge. Okay, that due to effective nuclear charge. The first reason. Then second reason, it is, so look at here, it is in this atomic number increases, number of proton also get increases. So number of proton, it is having the charge of the positive charge. Up a positive charge system, it is get increases. Okay, so then, and it is so that it is a nuclear charge also get increases. Positive charge increases in the sense nuclear charge increases. So this attraction is very effectively, so that is a size get decreases. So that it is increasing in the positive charge. From the lanthanum, look at here, from the lanthanum, atomic number it is 57. Look at lutetium, what will be the atomic number? 71. That will be the atomic number. So gradually atomic number it is increases, as well as the number of proton it is also get increases. Number of proton increases in the sense positive charge increases. That positive charge it attract the outermost shell electron very effectively. Okay, so this attraction between these two systems it is very effectively, so that due to the attraction, this outermost shell electron it is moves towards to the nucleus, like this. Actual atomic radii from this to this, and after it is attraction, it is atomic radius get decreases. Okay, due to the nuclear charge, effective nuclear charge. Due to the effective nuclear charge, atomic radius gets decreases. Atomic radius in the sense in distance between the center of the nucleus to outermost shell of an electron in an atom. Children, listen me very carefully. So that gradually with increasing in the atomic number increases, number of proton also get increases. Number of proton it is increased. If it is increasing the proton, if it is increasing in the positive charge in the nucleus, that charge it is called as nuclear attraction, nuclear charge attraction. Due to the nuclear charge attraction, it attracting the outermost shell electron this very effectively, so size get decreases. That is we called as a lanthanoid contraction. Okay. So look at this one, lanthanum, lutetium, so lanthanum, cerium, praseodymium, neodymium, it's going up to the case of lutetium. This gradually number of proton it is get increases. So look at here, this is the atomic number of 57. So that is a 57 positive charge. Okay, here it is the 58 positive charge. In praseodymium, 59 positive, and neodymium, it is a 60 positive. Then promethium, it is 61 positive. Then lutetium, it is a 71 positive. Gradually. So in between this, some other element also there. So that due to this, okay, so look at here, attraction force between the nucleus and outermost shell electron be like this. Only this much of attraction force it will be existing. But if it is increasing the atomic number, charge also get increases. Positive charge it is get increases. So that it is comparatively lanthanum, cerium get greater attractive. Comparatively cerium, prosodium, it is get a greater attractive. Look at children. Okay, so comparatively your prosodium, neodymium, it is will be very greater attraction. Then promethium, then lutetium. The lutetium have the very higher attractive forces. Higher attractive forces. Okay, lutetium have the very higher attractive forces. Due to the high attractive forces, high nuclear charge attraction, so size get gradually decreases. That decrease in size only that we called as a lanthanoid contraction. Lanthanoid contraction. Tell me children, it is a lanthanoid contraction. Okay, due to the increasing the nuclear charge attraction get increases. Nuclear charge attraction increases means size get decreases. That decrease in the size is called as a lanthanoid contraction. That's we called as lanthanoid contraction. The first reason it is over. The second one, shielding effect. Otherwise, we can also refer as screening effect. Okay, screening. This is my s orbital. S orbital. That will be very greater shielding. Okay, then what it is the order of the screening effect or shielding effect? Already I explained you. And s orbital have the greatest screening, then followed by p orbital, then followed by d, then followed by f. Okay. Tell me children. So that s orbital have the greatest screening. I will show you. See, look at here. That's greatest screening. It is not possible to attracting the outer shell electron. Present outer shell electron attract panna mudiyala, because that will be the previous inner shell electron will be as s orbital as a screening, greater screening like this. Next up, p orbital, somewhat lesser screening, that less than the s subset. Okay, it is attractive force between the nucleus and outer shell electron or valence orbital electron. Okay, somewhat it is a greater attract. Then next, in case of your d orbital, okay, so you just listen me. If it is s orbital irukku appadina indha edathila no gap at all. Okay, you just imagine. Okay, indha edathila oru holes me kedaiyadhu. But in the s orbital, p orbital la pathinga appadina, it have some holes in between them. It have some holes. Okay, due to from this holes, attractive force will be operated. Okay, so that it is less over shielding. But in the image see in the that is greater attractive. Okay, greater attractive. That is d orbital shielding that will be very poor. F orbital no, very poor at all. Example for octopus பாத்தீங்க. இப்போ for example ஒரு சுறா எடுத்துக்கலாம், ஒரு octopus எடுத்துக்கலாம். Okay, suppose you just it is stand in back side of the sura. அப்படின்னா அது ஒன்னு அட்ராக்ட் பண்றதுக்கு எப்படி ட்ரை பண்ணும்? that it is moved back side, then only it is going to attack you. Suppose octopus இருக்குன்னு வெச்சுக்கோங்க, you also stand back side of the octopus. அப்ப எப்படி இருக்கும்? நீங்க back side இருந்தா கூட that have the 8 legs, so that it is attracting easier like this. So d orbital and f orbital be like this octopus legs மாதிரி more attraction. So ஏதாவது ஒரு வழியில attract பண்ணிடும். So shielding effect, it is very poor. So that attraction, if it is a shielding effect poor means attractive it will be greater. So that it is attracting, it is very effectively. Right. Next one paranga. And based on this problems, So now we complete in the lanthanoid contraction. This lanthanoid contraction, what are the main reasons to operating the lanthanoid contraction? That is first reason, effective nuclear charge. Second reason, it is screening effect or shielding effect. Okay. Then let us move on to the problems. What are the causes of lanthanoid contraction? That is both the reason. Okay, effective nuclear charge also one reason. Shielding effect also will be the another reason. So both A and B. Next question. What is the effective nuclear charge? Effective nuclear charge, attraction between nucleus and outer shell electron. Okay, nucleus and the outermost shell electron. Then which of the following subcells has the strongest shielding? Strongest shielding. That is, s orbital have the greatest shielding effect and f orbital has the poor shielding effect. Poor shielding effect. Okay. Size of the lanthanoid matrix goes on. It is gradually in nitropore. It is get decreases. It is get decreases. That steady decrease in atomic and ionic radii in the lanthanoid or actinoid, that's we called as in lanthanoid contraction as well as in the actinoid contraction. That's is over. Okay. Then effect of lanthanoid contraction. What are the effects is mainly discussed? Okay. The effects of lanthanoid contraction, and that is size, almost similar size. That's zirconium and hafnium, niobium, tantalum, molybdenum, tungsten. That is after it is lanthanoid. Okay, that is a post-lanthanoid and otherwise we called as post-lanthanoids after it is lanthanoid. So these size, due to the lanthanoid contraction, these size it is get decreases. Actually, lanthanum to lutetium, it is atomic number 71. After it is lutetium, atomic number 71. Then after it is following the zirconium and the hafnium, niobium and the talum, molybdenum and tungsten. Okay, after it is continuing the atomic number. So that will, it is same size because due to the lanthanoid contraction. Okay, that is zirconium present in this case, hafnium present in this case. Niobium, it is present in this case of your fourth period, sixth period, sorry, this will be in the fifth period. And niobium, then tantalum, molybdenum, then tungsten. But actually, comparatively, zirconium and hafnium, it is down to groups that will be higher atomic mass, higher atomic size. But due to lanthanoid contraction, then hafnium, tantalum, tungsten, somewhat similar atomic radii with the previous group element. Okay, previous period element. Next one, it is basic strength, decrease in the basic strength. Because basic strength in the sense, like let's say for example, lanthanum hydroxide to lutetium hydroxide. The basic strength it is gradually decreases. Because basic strength which is directly proportional to atomic size. So that basic strength decreases down the group because due to the size. So look at in this case, lanthanum hydroxide that will be in a larger in size, then hydroxide. Okay. Then, but it is comes to up to lutetium hydroxide that will be in a smaller size. Then it is hydroxide. See, so if it is in a larger size means it is a larger in a bond length. If it is in a larger in the bond length, so you can easy to breaking the bond so that easily hydroxide ion donor. If it is donating the hydroxide ion easily, that will be greater basic. But this lutetium, it is smaller in size. So that attraction, it is, I mean, bond length, it is get decreases. Bond length get decreases. So it is somewhat, it is lesser tendency to donating the hydroxide ion. So this is the reason. Basic strength get, it decreases gradually. Another reason, another effect, it is post-lanthanoid effect. These reasons are these are effect of lanthanoid contraction. So students, please subscribe the channels. And இது மாதிரி கண்டினியூவா என்ன ஆயிட்டு இருக்கும் அப்படின்னா இம்பார்ட்டன்ட் கண்டென்ட்டுக்கு வந்து உங்களுக்கு வீடியோஸ் கொடுத்துட்டே இருப்போம். யூ ஜஸ்ட் ஃபாலோ அஸ், சப்ஸ்கிரைப் பண்ணுங்க, தென் உங்க ஃப்ரெண்ட்ஸுக்கு ஃபார்வர்ட் பண்ணுங்க. தேங்க்யூ சில்ட்ரன்ஸ்.